Hey everyone, welcome back to yet another Euphoria Academia past paper video. So today we're going to be doing Mathematics Paper 1, the May-June 2023 paper. We'll be doing question 2 and question 3. My name is Ole and I'll be taking you through it. If you find any of our videos helpful, please like, share and subscribe. And please also comment if you want to see more questions like this. Without further ado, let's get into it. Question 2 and 3 form a total of 26 marks, and they start from question 2.1 all the way up until question 3.2. For question 2.1.1, we're asked if the geometric series is converging or if it's diverging. Right, so we already know that we have geometric series, so we just have to find the value of r, and the value of r will be equal to the second term, divided by the first term. And as we substitute that, we're going to see that that is essentially going to be 1 over 15 divided by 1 over 5, and our result is going to be 1 over 3. Now this 1 over 3 is actually in between -1 as well as 1. Therefore, we know that if it's in between, the series is convergent. Just like that, we answered the question. Question 2.1.2 asks to calculate the sum to infinity of the series. Now, because we know that the series converges, that means we can use the formula sum to infinity of is equal to a over 1 minus r. Now, we just have to substitute the values of each variable. So a, which is our first term, we know that that is 1 over 5, and then r, we got that in the previous question, and that is equal to 1 over 3. If we substitute, our sum to infinity is equal to 1 over 5 divided by 1 minus 1 over 3. And if you put that in the calculator, you will find that our sum to infinity is equal to 3 over 10. For question 2.2, we're told that an arithmetic and a geometric sequence are combined to form the following pattern. I'm just going to rewrite the pattern. That is going to be Pn is equal to the first term is x, second term is 1 over 3, third term 2x, then we have a 1 over 9, and then we have a 3x, and then we have a 1 over 27, and it continues. All right, so we're told that there's a combination of arithmetic as well as a geometric sequence. Right, now for the arithmetic, we know that through every term there's a common difference of d. Right, so let us try and find that in what we have here. So it's a combination, so that means we probably have to look at things that alternate, right? So this x can be mapped to that 2x, and the 2x can be mapped to 3x, and then the 1/3 is mapped to 1 over 9 as well as 1 over 27. Now we can see for the numbers, so the 1 over 3s and the 1 over 9s, that there seems to be a change of 1 over 3 as we move from 1 over 3 to 1 over 9 to 1 over 27. We're multiplying by 1 over 3, so that is our constant ratio, so that's our geometric series. And then for the x's, we have x, 2x, and 3x. You can see that there's an addition of x, and that's our common difference. So to answer the first question, we're asked to write down the next two terms. So we know that they alternate, so the next term after this 1 over 27 will have to be mapped to the 3x, and we know that we add an x, so the next term is 4x, and then the following term is mapped to the 1 over 27. If you multiply that by 1 over 3, we're going to find that we have 1 over 81, and that is our answer. Question 2.2.2, we're asked to determine the general term for the odd terms of this pattern. And we should write down our answer in terms of x. Now in the question, they already gave us a hint that it should be in terms of x. And we saw that our first term is x, our third term is 2x, so these are the odd numbered. And we already said that our common difference is d, which is x, and our first term is x. Now for an arithmetic series, the general formula is Tn is equal to a plus n minus 1 multiplied to the common difference t. Now let's just substitute what we have. Our first term is x, and then n minus 1 multiplied to x. Now let's distribute and simplify this. We have x plus xn minus x, and our Tn is equal to xn. For question 2.2.3, we're asked to find the 26th term, right, in the number pattern that we have. Now this 26 can be seen that it is an even number, so it is part of the geometric series that we have, all right, but it's not going to be the 26th term of the geometric series, but rather, because they alternate, we're going to divide that 26 by 2. That is going to give us 13. So it's the 13th term of the geometric series, and we're just meant to find the value of it. All right, so we already know that our general formula for geometric series, Tn is equal to a r to the power of n minus 1. Now our a, we noted it down as 1 over 3, and our r was also 1 over 3. So let us substitute. Actually, let's substitute everything. So our 13th term is going to equal 1 over 3 multiplied to 1 over 3 to the power of 13 minus 1. And when we put that into our calculator, we're going to find that we get an answer of 6.27 times 10 to the power of negative 7. So a very small number. For question 2.2.4, we're given a sigma of our pattern being equal to 33.5. So let us write the sigma to see what it means. All right, n is equal to 1, and what is the formula? What's the pattern? The pattern that we have is our Pn, so what we have in the beginning of the question, and we know that it's ending at 33.5. all right, okay, so we know our starting index is equal to 1, and then our end index is equal to 21. All right, so we also know that our Pn is a combination of our arithmetic series as well as our geometric series. All right, so Well, we know that the sum of the arithmetic and the sum of the geometric is going to give us a total of 33.5. But this term is a combination and it ranges from 1 all the way up until 21. Now we know that we alternate between the two. So the odd terms are the arithmetic series and the even terms are the geometric series. But we need to determine exactly how many we have, how many terms we have of each. All right, so we're going to take 21 divided by 2, and the answer that we're going to get is 10.5. All right, so shared equally, there should be 10.5 arithmetic terms and 10.5 geometric terms. All right, but we know that we actually start with an odd number and end with an odd number. So if you count it out, you will see that for the arithmetic sequences, we actually have more. We have 11 terms because you can't have half a term. They don't share half a term. They're very distinct. And our geo terms, conversely, since we have 21 terms, they need to add up to 21. That means we're going to have 10 geometric sequences. Now we need to use what we know to find the value of x. All right, so let's write out what we just have. We have the sum of the arithmetic terms up until 11 of them plus the sum of the geometric terms, and we have 10 of them. That will give us 33.5. So let us calculate what we have from the sum of the arithmetic terms. Now, sum of the arithmetic, we have 11 of them, and that will be equal, the general term of arithmetic sums is n over 2 multiplied to 2a plus n minus 1 multiplied to d. Now let us substitute. So I'm just going to write SA11 is equal to 11 over 2 because we have 11 terms, and 2a, our a is going to be x because that's our first term, and then n minus 1, that is just 11 minus 1 with common difference of x. So let us work that out. If we work that out, we're going to see that, okay, let me do it step by step. Going to get 11x plus 55x, and that will be equal to 66x. Now for the geometric series, we have 10 of them, and for geometric series, the formula for the sum of the terms is a over 1 minus r to the power of n divided by 1 minus r. So we're just going to substitute what we have. Our a, we said that was 1 over 3. That is 1 over 3 multiplied to 1 minus our r is 1 over 3 to the power of 10, and that will be divided by 1 minus 1 over 3, and when you put that into our calculator, we're going to find that we have the sum equaling 0.5. Now we're just going to substitute what we have here in our results to this term here. All right, so we're just going to substitute that into that. So we're going to see that 66x plus 0.5 is going to give us a result of 33.5. Now, after doing some maths, we find that x is equal to half. Right, question 3.1, we're asked to show that our Tn is equal to 5n squared minus 15n plus 16. Now we're given a whole story about we have a quadratic sequence that has the following properties. So the second difference, our second difference is equal to 10, and then the first two terms, so T1 is equal to T2, I'm just going to call them x, and then our T1 plus T2 plus T3 is equal to 28. So in this case, this will be our 2x plus T3 is equal to 28. Therefore, I guess T3 will be equal to 28 minus 2x. Alright, so we already know that we have a quadratic sequence. Alright, so what we do know is for a quadratic sequence, they all have the same second difference. So they have a common second difference. Alright, so I think it's best practice to work with about 3 or 4 terms to help us out with this calculation. So we're going to have T1, T2, T3, and then T4. Alright, so our this T1 and T2, that's our first and second term, and we're told that our first term is equal to our second term, so T1 is going to be x and x, and the difference between these two, x minus x, that's going to give us 0, and we know that we have a common second difference of 10. Now we're just going to work our way up. Now if we work our way up, instead of subtracting, we add. So 0 plus 10, that gives us 10. And now we're working our way up to term 3. So x plus 10 is actually x plus 10. And let's go down again. We know that that's going to give us a common difference of 10. They have the same common difference. So 10 plus 10, that is going to give us 20. And what we have here is x plus 10 plus 20. We're going to see that we have an x plus 30 as our term 4. Alright, so let us find what our x is equal to. So we are also told that if we add our term 1 plus our term 2 plus our term 3, we're going to find that that is equal to 28. Now T1 plus T2 plus T3, that actually stands for, or you can look at it as the sum of our first 3 terms. So S3 would be written as such. S3 is equal to T1 plus T2 plus T3. And we know that if you want to find any term number, that is equal to the sum of the terms up until that point minus the sum of the previous terms before you got to this last term n. Alright, so we already know that we already have an idea of what our T3 is. So our T3, let's just try and find our sum of the first 3 terms, and is S3, and that will give us minus S2. All right, so our T3 from our diagram, we can see that that is x plus 10, and then our sum of the first three terms we're given that that is 28 minus our S2, and our S2 is the sum of our first two terms, and that is x plus x, and that is actually minus 2x. Sorry, this is meant to be a 0, that is x plus 10. Alright, so after doing some algebra, we're going to see that our 3x is equal to 18, therefore making our x equal to 6. So after finding our x, we can just substitute what we have for x in our diagram, and our x was 6 to give us the following diagram. Now, to find x wasn't the main part of the question. The main part of the question was to show the general formula of our quadratic sequence, right? So we know that the common second difference is equal to 2a, right? And then the first difference of the first two terms, that is 3a plus b, and the first term is equal to a plus b plus c. Alright, so let us compute what we have for the names of our variables, or the values of our variables, right? So 2a is going to be equal to 10, therefore a is equal to 5. Alright, and then our 3a plus b, that is going to give us a value of 0. Let us substitute what we have for a, and that is 5. So 3 times 5 plus b is going to give us a value of 0, and we will find that b is equal to negative 15. And finally, our a plus b plus c is equal to 6, and our a is 5, our b is minus 15, and we're trying to find c, and that is equal to 6. When you do the mathematics of it, we have 5 minus 15, that is going to give us a minus 10. If you take it to the right hand side, you will find that our c is going to give us 16. Now, the general formula of a quadratic sequence is Tn is equal to an squared plus bn plus c. So let us substitute what we have for our variables a, b, and c. We have that a is equal to 5n, and that's going to be 5n squared. Let's not write a plus here, because we have a minus 15n, and that is, the c is going to be 16, and that matches what we're meant to show. So our final answer shows what we're required to show. 6 marks. Question 3.2 asks if 216 does that form part of the term? So 216, will that be a value in the term Tn is equal to 5n squared minus 15n plus 16? That's what it's asking. It's not saying that that is the term number, but is it a value that this sequence will produce, essentially. So all we're going to do is substitute 216 into our general formula, and that is going to be 216 is equal to 5n squared minus 15n plus 16. And just a note, if you are not able to do question 3.1, it's advisable to continue with 3.2, because you can just use whatever answer that you have from 3.1 that they tell you. So we know that the journal sequence is this. So you can still continue. You don't have to skip the question and lose 9 marks in total. You can just get 3 at least. So let us continue. If we're going to do that, let's just take the 216 to the right hand side and just switch things around so that things are a bit more legible. So we're going to subtract 216, we're going to subtract 216. So what we're going to be left with is 5n squared minus 15n. That will be, and then our c value is going to be minus 200, and that is going to be equal to 0. Now we're going to substitute what we have into our quadratic equation. So our a is equal to 5, and our b is equal to minus 15. Our c is equal to minus 200, and our n value will be equal to minus b plus or minus the square root of b squared minus 4ac, and that is divided by 2a. And let us just substitute what we have. N is equal to minus, our b is minus 15 plus or minus the square root of minus 15 squared minus 4. Our a is 5 and our c is minus 200. And all of that is divided by 2 times 5. We will see that our n is, when you put that into your calculator, our n is equal to 8, or you will get another answer that says n is equal to negative 5. But you can't have a negative term because the term numbers are elements of our natural numbers, so it cannot be equal to negative 5. So our 8th term, so our T8, will actually be equal to 216. So therefore, yes, the term exists. Let's just say that the term exists, and that is our question.